Hey everybody, Mike Wiesing here, and I'm in the lab in Plano, Texas at the headquarters for Lite-On Technologies Power System Solutions Group. And today I'm going to demonstrate VPOC. VPOC stands for Virtual Power on Call, and VPOC is designed and manufactured by Lite-On Technology. You may not be familiar with Lite-On, but there's a pretty good chance you're using Lite-On product every day. Let me give you a couple examples. Here in my hand is a small cell phone charger, or maybe a pad device charger. Lite-On builds these for many major manufacturers. So if you're using a charger like this, very good chance or probability that Lite-On built that charger. And I'm getting to something by introducing Lite-On as building these little power supplies and chargers like these. For instance, this is my power supply from my laptop computer. Lite-On is the world leader in these types of power supplies as well, and Lite-On builds these for many major manufacturers. So pretty good chance if you have a laptop and you use it on a regular basis, you're using a Lite-On power supply on a regular basis. But I'm going to give you a better example, and one that has a little bit more meaning to this demo that I'm doing today. Lite-On is the world leader in building what we refer to in the industry as the silver box. Of course, the reason may be because the box is silver. This is a power supply that would be very similar to the embedded power supply that you would find in each one of these 4 servers that I'm using for this demonstration today. Now, these 4 servers were picked randomly. They're name brand servers. I've got an HP server, a couple Dell servers, an IBM server. We could have a switch of any brand manufacturer here for the demo. Again, these were randomly picked. What I'm going to do today is talk a little bit more about VPOC and what it's designed to do. Again, VPOC's a 10 kilowatt uninterruptible power system when combined with this silver box. In other words, these 2 items come together as a package to create the UPS system of the future. Some things about VPOC in comparison. If you look to my right here, this is a kind of a standard conventional 10 kVA UPS. 10 kVA, maybe 8 or 9 kilowatt UPS. On the bottom I have my batteries. On the top I have my electronics. All in all, this uninterruptible power system takes up 6U of valuable rack space. That's expensive real estate, and it has a lot of electronic and electrical parts. When you compare to VPOC, much smaller. VPOC is 10 kilowatts true power. It takes up 1U in your standard EIA 19-inch rack. And guess what? The batteries are in the VPOC system, and they come as a pull-out module. That'll be for another demonstration, but understand that the batteries are in the system. Okay, so what I'm going to do today is I'm going to do a demonstration. I'm going to show you that what happens when VPOC experiences a power event, whether it be a sag, a surge, a blackout, a brownout, one of many different power problems that could occur. First, let me explain that we are feeding currently 208 volts AC 60 hertz to the input of VPOC. VPOC in turn is feeding that 208 volts AC through its PDU that is part of the VPOC system into those silver box power supplies that are embedded into the back of this IT equipment, and then these power supplies are feeding the servers, the IT equipment, the 12 volts that they need native to run the way they do. All right, so what I'm going to do is I'm going to simulate a blackout with VPOC, and I'm going to show you how it reacts to the power completely being cut off. Could be during a storm, could be any event, any number of events that would cause a blackout. And the way I'm going to do that is I'm going to cut the power from my AC source to VPOC by simply pushing a button. When I do that, we're going to notice a power loss on the input of VPOC on our power analyzer, and on the channel 2 of the power analyzer, we're going to notice that there's still a voltage on the output of VPOC, and that the IT equipment through the PDU, through the embedded power supply, is still being fed power to operate like they're designed to. So at the count of 3, I'm going to push the button on my AC power source. We're going to watch right here where VPOC loses power, and then I'm going to explain to you what happens after the fact. So at the count of 3, we're going to simulate a power outage. 1, 2, 3. Button pushed, voltage cut off to the input of VPOC. We're approaching 0 volts on the input. Right now, VPOC's output is measuring 261 volts DC. Let me explain that. VPOC's output is 260 volts DC. Now VPOC is made to operate within a certain range, in the neighborhood of 240 volts. The IT equipment now is running on 260 volts DC to the input of that silver box, and it's converting that to 12 volts DC and other voltages that the equipment needs to run. What happened, if you look at my oscilloscope, right at about peak power during my cycle, I lost power completely. And I went to 0 voltage for a very, very short time. On the output of VPOC, you can see again where I lost power. Went to 0 voltage for a very, very short time. A time under 4 milliseconds, a time that is undetectable by this IT equipment. This IT equipment never saw a power outage. So we switched from AC, 208 volts, to DC, 260 volts, give or take, on the output of VPOC, through the PDU, into the IT equipment. And guess what? This IT equipment is running exactly like it's designed to. That power supply that we design and build, and we understand very well, is working in unison with VPOC to create the future of uninterruptible power systems. Now what I'm going to do is I'm going to push the button on my AC power source, and I'm going to bring AC power back to the input of VPOC, and we're going to see what happens. Okay, I pushed the button. We're back to 208 volts AC on the input. VPOC's operating perfectly. All the equipment's operating perfectly. I look at my oscilloscope. I've got 60 hertz, 208 volts on the input, 60 hertz, 208 volts on the output, going through the PDU, 208 volts here. Again, 208 volts on the output of VPOC. Everything's operating exactly like it's designed to do. So what I've done here is I've shown you that VPOC switches very quickly and that it does exactly what it's designed to do. And that is protect the downstream equipment from a power outage or a power event. We really appreciate watching this video today. If you have any questions regarding VPOC or how it operates, please watch the credits and you'll see our contact information there. Thank you very much.